Welcome back to the morning show. Coming up on 6:50 this Wednesday morning. That only means one thing. Wise guy Matt's time. Our U of I physics professor Matt Selen is in, and have you noticed, Matt, this is your table now. They've given it to you since we got a new one.
Well, because it's all dinged up and stained and burned, probably
and
because of me and Jesse, right? That's pretty good.
Yeah, he did burn it. So you and Jesse have this table for whatever you want.
It's a competition. I have to do more damage than that next time. Okay, I'm going to try to do that.
Right.
Before I start, I just want to say happy birthday to my daughter Kathy.
Oh, awesome!
Who is 18 years old today. And
awesome.
Yes, that's very awesome. And she just found out last week she got into the U of I, so I'm really excited.
Well, very good.
So, anyways, we're going to talk about Christmas lights because they're sort of interesting, and I just love Christmas.
Okay.
I got to tell you this. And so I've been decorating at home, and like everywhere else. So what I did was a bad thing. I left the Christmas lights I had hanging outside, these little white icicle things. I just left them there all year, and I just plugged them back in at Christmas. Okay, and so half of them didn't work.
Right.
So I thought, okay, I got to really fix these things now, and fixing these things is a real nuisance because what happens is these bulbs burn out. So let me explain how these things work to begin with.
Okay.
These are the regular kind of lights, the same as the regular light bulbs in a sense that what happens is there's a little filament in each one of these. Current goes through it gets really hot, and what you're seeing is the white hot glowing piece of metal in there, and that's how a lot of light bulbs work and used to work. And so these things have the unfortunate feature that they just kind of burn out after a while. And so, but what they do, though, is they're very clever when they make these things, because otherwise, the way these things are wired up is that they put 25 in a row, and then they'll have a separate circuit where there's another 25. So if you look at these, for half of a string, they'll be sort of 3 wide. Then there'll be a little space where there's only 2, and then there's 3 wide again. And if I pull one of these bulbs out, this whole set dies, but that thing keeps going. Now, these things don't last very long, so this string would be gone instantly if they didn't have some clever way of dealing with this. So that what they do is each one of these little bulbs, when the thing actually burns out, you'll get a slightly bigger voltage. You get a bigger voltage across this. That's what happens. And then there's a thing in there that just shorts it out. So if you look very carefully at a big strand of lights on your tree, you see a lot of the bulbs are dark. They're not working, but they're shorted out because that's the way these things are supposed to work. Okay, but sometimes they don't short out the way they're supposed to and keep the circuit going. And so what you can do then is you can get a little gadget like this thing.
I've seen that.
Which doesn't work that well. But anyways.
I've heard that as well.
It's supposed to work this way. That you can stick it in here. You can take one of the lights out and you can plug this thing in like that. Okay, and then you can give a little shot of electricity, a little extra jolt. The same kind of voltage that was supposed to fuse the broken bulb in the first place might help it along and sort of fix it. And so every now and again that'll fix it, but usually you just have to rip it out and throw it out and get a new one. Now, I'll tell you what you can do with that in a second. Nowadays, you can get these things which are LEDs. These are awesome. And if you look at them, they have this interesting feature that they kind of flicker if you move them around. Okay? And it's because LEDs work completely different from these things. Instead of converting current into heat, into light, these things convert current directly into light. But they only conduct in one direction. And the current that comes out of the wall socket goes first one way, then the other, and it changes around 60 times every second. And, or 120 times every second, actually, it changes. And so what happens here is these things only are on when the current's going one way, and it's off when it's going the other way. So that's why these things are 60 times a second. You see these things flash, and you can see that they flash. If you spin them around like this, you see that they're not on all the time. You can sort of see where, if you spun this thing around, you would just have, right? You see the lights all the time. On this thing, they sort of flicker, and they're only on for part of the time, all right? Okay. So finally, what you can do, okay, if you have an old string and it doesn't work anymore, ask your parents, and you can take it apart, and you can actually learn about electricity by just using Christmas lights and a little 9-volt battery, which is kind of nice. So you can take these regular lights, and you can put a whole bunch in a row like this, and you can see that you can make them light up. And you see these things are not very bright because I have so many in a row that divides the voltage up. If I just stick one of these on here, 9 volts is really way too much voltage. And it's very, very bright.
It's like Rudolph bright.
Yeah, with the LEDs you can do the same thing, but here you'll see the interesting fact that if you put them on the battery one way, they work. If you put them the other way, they don't work. It's a one-way switch. Current only flows one way through these things. Because we have to blow one thing up, I'm going to take one of these, put it on the battery. If I just do it on one, it flickers for a second, and then it goes out, because these things had no way to limit the current. The thing just melted, basically. Okay. So,
there you go.
Are we out of time?
Yes,
we are. Okay, I'm sorry. I talked too long.
No, it's all right. Don't worry about it.
So, Merry Christmas, everybody.
Oh, well, thank you, Matt. Thanks for coming in today. We appreciate it. You want to see a replay of the segment, learn all about electricity?
You ran past my 3.
Oh, you're coming in?
You guys.
You're in trouble.